In this video we will create a neural network in Unity. Neural networks are at the heart of modern AI technologies like ChatGPT. We will write all the code to create a neural network ourselves. Then we will train our neural network and hopefully we will be able to use it to let these poor guys walk to the portal without falling down. Let's get started. So what is a neural network? The brain consists of many brain cells, neurons, and they are surrounded by dendrites. These dendrites are connected to other dendrites by synapses, and through these dendrites and synapses signals can be sent from one neuron to the next. So many neurons are connected in that way, and they can learn how to respond to certain signals. So for example, if a neuron receives a certain amount of signals from the dendrites, it will become active. So we can train this network to respond with a certain output based on a certain input. For example, if our eyes see the shape of this letter, then that could be an input to our brain. And when somebody tells us many times over that this is the letter S, we can connect it to a certain output that represents the letter S. And after that, we are able to very quickly recognize the letter. Even if there is a small deviation of the shape, the network is still strong enough to make these neurons active when we receive an input that looks a lot like the input shape of the S. Okay, so now let's run over the code of the neural network. We only need 5 C# classes to represent the neural network. I've put them in a separate folder and they also have a separate namespace. The first script that we need is the cryptorandom. It generates random numbers. Those are needed by the dendrites because they are initialized with random weights to make the network asymmetrical, so it can find quickly the best values for the weight. Over here you see the dendrite class. This represents the dendrites. There are many dendrites connected to every neuron and they have a certain weight. Then we have the layer class that represents a layer. We have the output layer, the input layer, and the hidden layers, and each layer consists of a number of neurons. Then we have the main class, the neural network class. It has some variables and some functions over here to give us some statistics about the neural network. It's not that important for now. And over here we have the constructors, which we can use to construct a neural network of a certain amount of layers and a certain amount of neurons in each layer. Then we have the sigmoid function. The sigmoid function determines if the neuron has become active or not. Over here you see a graph representing the sigmoid function. You can see that it's either low or high, and there is a small bandwidth in which it changes from low to high. So it doesn't go immediately from low to high. There is a certain slope in this graph because the neuron needs to be activated sometimes even when it's not completely this value. So at this point the value changes around to 0, but we can shift that point to the left or the right because the neuron also has a variable called bias, which we can use to change the activation behavior. And then we have these methods to train the neural network. We train the network by giving it some inputs and some outputs, and actually telling it that this input should be connected to that output. And if we tell that many times over, it will understand which input will be connected to what output. We can have different inputs that can have no relationship at all, and that's the great thing about the neural network. Even if we don't have any linear relationship, we still can use the inputs and give a proper output, as long as we learn it many times over, and the weights will be adjusted for the dendrites to make the neurons active at the right moment. So over here you can see the actual training function. We run the inputs, and then that we have a certain output, and we also have an output over here that we have that should be the right output, and then the neurons are adjusted a little bit towards that desired output. If we do that many times over, the neuron finally will get the right values. And over here we adjust the weights as well. So here is the running. This one is used both to train but also to predict the output. So we can call this function with a certain input, and we can then sample what the output layer has at that moment, and that's the predicted output of the neural network. Okay, so using the neural network is quite simple. We just need to give it some inputs and some outputs, and then we train it with those inputs and outputs, and then finally we will need to give it inputs during the time we are running, and we will use that output as the desired thing to do. So in our case, we want to move from this starting position to this target without falling, so by following the path to get there. This is not something that's easily done with a neural network, but I just want to show you that you can put the situation, and you need to think about how you can use the neural network to solve it. In a real life situation, this guy would have eyes, and he would slowly learn that this represents a floor, and if you step out of it and you see something like something very high, then you would fall. That requires a lot of training and many neurons. We don't have that big artificial network available on this PC, so we take a little bit a simpler approach. What we can also do is let this guy walk for a bit, and then make a turn, and then walk again for a bit, make a turn, and so on. And there are certain ways that he can walk and make turns that he will end up in this position without falling down. So that way we only need the angles at all those points where we turn a little bit, and that can be the output, because that's what we need to know. So what's the input then in that case? Well, actually there is no input, we're just standing here, and we want to get to there, so we can only do with the output, but of course that's not so interesting, because then we can just give this guy a certain amount of angles and he can just play back that that movement and end up here. So what we will also do is that we can spawn over here as well. And so this is a different input than this one, and it will result in a completely different output, because the road from this position to here is very different from the one from this position to here. So then we have two different input values, and we have a certain amount of output values that are connected to those inputs, and they represent the angles to get to the endpoint. Now first we need to know those angles. We can do that by trial and error, but we can also write a script to make it a bit faster. Let's just write a script that tries every angle and shifts a little bit every time until it finally gets to this point. Over here you can see how the program searches the right angles to get to the target. It does that by changing the angle with 10 degrees all the time until it gets further and further and finally reaches the target. By the way, when the persons are blinking red, that's the moment that they are changing their angles. Okay, so by using that trial and error with the angles, we found out that the proper angles to get to the target are those angles for the first position and those angles for the second position. As you can see, there is no real relationship between them. So that's something very interesting for learning to a neural network. Before we do that in the Unity program, I will use another program that I wrote earlier. It's a WinForms program, and it contains some user interface for running the neural network code. There are some different things this program is able to learn, like for example chess playing, but for now I've added this button Mr. Brain for the new application, the Unity game that we just wrote, and we want to run that through the neural network. So when you press this button, we construct a neural network with these properties. We have one input neuron, that's the spawn position, and we have 10 output neurons. They represent the 10 angles that we need to get to the target. So then we will just feed this program with the angles. Those are the same angles that were found with the with running the path program. And if we've done that, this network should be trained well enough to recognize the inputs of 1 and 0 for the spawn position, and to respond with an output of exactly the angles that we are looking for. The neural network uses neurons that have values between 0 and 1. So we need to convert our angles into neurons, and we do that by using this function. So we have angles between minus 90 and 90 degrees, and that's minus 90 represents 0, and plus 90 degrees represents 1 as a neuron value. So, and then if we have trained the network, we can test it by putting an input value in this field, either 0 or 1 for the spawn position. And then when we press this button, the output should be calculated by running the neural network again and by transforming those output neurons into angles again. So then we do the opposite over here. We take the output layer and we convert all the neurons of the output layer into angles again, to angles between -90 and 90 degrees. So let's run this program and see what happens. So we start training. You can see the number of trainings over here and some other statistics. We can also watch the neural network over here. This is the hidden layer and this is the output layer. You can see these values represent the angles, but in a value between 0 and 1. And they slowly should move to the desired value. So now the input is 1, the output should be some sort of degrees, and these values are constantly adjusting until they have the right value. We've done quite a lot of training already, so maybe the system is already capable of responding with the proper response. So let's check it by pressing by putting in a value of 0, spawn position 0. This is the current output. You can see over here this is the desired output, so it's already the desired output. And the same goes for the second spawn position. So if we run the network again, but with a slightly lower learning rate, let's say 0.5, it will now start over, and it needs to learn again. So let's check out if it's now giving the right values. Now you can see now that it's not giving the right values yet. The -30 is okay, but this value of 45 should be 40. So, and now it's already 41. So you can see that it's moving quite quickly to the proper value, but it takes some time to reach it. Okay, now let's take a look at how this neural network code is embedded into this Unity application. We got the character spawner that spawns the characters that you see on the screen. We give them a movement plan, so they have a certain plan of angles which they will use every time they need to make a change, and that way they move in a certain pattern and they can reach the target. So this pattern comes from the neural network, and the neural network is instantiated inside the game class over here. So we take a plan from the neural network by giving it the proper spawn position, and then running the neural network inputs, and then recording the outputs. And those outputs are the angles that this character should use. So once this neural network is trained, it should be able to respond with the proper angles. But initially, of course, it isn't. So when you press this training button that's on the screen, then we construct a new neural network with the properties. And we also start a coroutine over here, train neural network. It's over here, and it's performing the training. So it takes 200,000 iterations to train it about the first and the second spawn position. And in the meantime, it gives us back statistics and gives us a little bit of time to to update the statistics and stuff. So this will run in parallel, so we can at any moment we can use that already partly trained neural network to spawn new people, and they will use the new updated neural network. So hopefully they will continue to be walking more properly after a bit, after they've been trained. So first, without training, you can see that the guys are falling quite quickly onto the floor. The average distance is about 11. And now we've started the training. You can see the number of iterations. And step by step, the guys are moving further because their angles they learned about are getting more correctly all the time. And finally, when we have about 12,000 iterations, the guys know how to walk to the target. So the network is fully trained by then. So that concludes our video. We have seen that it's relatively easy to write code to implement your own neural network. However, using the neural network to its best requires some creative thinking, and in many cases lots of processing resources. As always, the code of this project can be found with the link in the description. Thank you for your time, and see you in another video.